In this problem, I'm going to take a quadrilateral that I'm given coordinates for, and I'm going to determine what kind of quadrilateral it is. The directions would probably say something like, give the most descriptive name for the quadrilateral with the vertices -9, 1, -3, -7, 9, 1, and 3, 9. And you can do this primarily with the slope formula and the midpoint formula. One of the things I like to do early is try to figure out if my shape is actually a parallelogram, because that really narrows it down. And a very easy way to do that is to look at your diagonals. The diagonals of a parallelogram bisect each other. So you can find the midpoints of your two diagonals, and if they both have the same midpoints, you know that the diagonals bisect each other, in which case you have a parallelogram. If they don't bisect each other, you probably don't have a parallelogram. So I'm going to find the midpoint of segment BD, okay? If you remember, you can find a midpoint by averaging your x's and averaging your y's. So you're going to add your x coordinates together, divide by 2, add your y coordinates and divide by 2. So that's going to be -9 plus 9 divided by 2, and that's going to be 1 plus 1 divided by 2, and midpoint's going to be the point 0, 1. Okay, that's where that point's happening on that segment. Okay, so that length there would be equal to that length there. The question is, does this segment also get bisected? If that point that's the midpoint of those two segments is the same for both lines, we know they're bisecting each other. So I'm going to find the midpoint of AC, okay? I'm taking 3 plus -3 and dividing by 2. And then I'm going to take 9 plus -7 and I'm going to divide by 2. And I end up also getting 0, 1. Okay, so 0, 1 is the midpoint of that segment, 0, 1 is the midpoint of that segment. Those diagonals bisect each other. This is some kind of a parallelogram. So I don't have to worry about it being a kite. I don't have to worry about it being a trapezoid. I know some kind of parallelogram. Now, is that the only way to tell if it's a parallelogram? No. Okay, you've got other options. For example, you could find the slopes of the sides, because shapes with sides that are parallel, the opposite sides would have the same slope. Okay, so you could use the slope formula. Change in y, y2 minus y1 over the change in x, x2 minus x1. And for example, I could find the slope of BC. Okay, y2 minus y1, that's 9 minus 1. x2 minus x1, 3 minus -9. That's going to be 8 over 12, which is 2/3. Okay, so that slope there is 2/3. Let's see if this slope down here is also 2/3. If it is, we've got at least one pair of parallel sides. So let's do AD. That's going to be 1 minus -7, 9 minus -3. Once again, we get 8 over 12, which is 2/3. Okay, so one pair of opposite sides are parallel. If you're trying to show this was a trapezoid, you'd have one pair of parallel sides. You basically would just want to show that these sides are not parallel. In this case, though, I want to show that they are parallel because we're pretty sure it's a parallelogram. We're just trying to show it a different way. So I can come back, and now I can find the slopes of the other two sides. We can find the slope of CD. That's going to be 9 minus 1 and 3 minus 9. And on top, that's going to be 8. On the bottom, that's going to be -6. That's -4/3. Okay, there's that slope. If this is going to be a parallelogram, then this slope needs to be the same thing. So I'm going to find the slope of AB. Slope of AB, 1 minus -7, -9 minus -3. We get 8 on top. On the bottom, 9 minus -3, same thing as adding, and we get -4/3. Okay, so now you can see a second way. You don't have to show both of these, but you can see a second option. Both pairs of opposite sides are parallel. Okay, now, could be some other kind of parallelogram. Well, the other thing you can do is you can look and see, are the sides perpendicular to each other? Okay, remember that perpendicular lines have opposite reciprocal slopes. In other words, one line has a slope of 6, the perpendicular to it would be -1/6. If you take a look here, 2/3 and -4/3, they're opposites, but they're not reciprocals, okay? These are not perpendicular. This does not have right angles, meaning it's not a square, also means it's not a rectangle, okay? Now, there is one final thing. Could be a rhombus, okay? You know, it could be a parallelogram, and maybe it's got 4 congruent sides, but just no right angles, that sort of thing. Remember that rhombuses have perpendicular diagonals. So once you've found it's a parallelogram, you can come back and look at the slopes of the diagonals, and you can see if the diagonals are perpendicular. That could also be used for a kite. You could do a midpoint of one of the diagonals and show it has a bisector, and then you could show the slopes of the diagonals are opposite reciprocals and they're perpendicular. We can do the same thing here. BD's slope is going to be real simple. It's 1 minus 1 and 9 minus -9. That's going to be 0. Okay, it's perfectly horizontal if you didn't notice that. The slope of AC is 9 minus -7. On the bottom, it's going to be 3 minus -3. And that's going to be 16/6, which is not the opposite reciprocal of 0. Okay, so the diagonals are not perpendicular, meaning it's not a rhombus. Again, we've got 2 pairs of opposite sides, so it is a parallelogram. So primarily finding midpoints of diagonals to see if the diagonals bisect each other, finding slopes of diagonals to see if your diagonals are perpendicular, and finding slopes of sides. If you look at all those things, you should be able to tell if your shape has right angles, if it's a parallelogram. If it is a parallelogram, if it falls into a rhombus category. Of course, if it's a rhombus and a rectangle, then it's a square. If you can show it's got perpendicular sides and the diagonals are perpendicular to each other, you've got that option. So a lot of different things you can check. You know, looking at a picture helps you kind of guess what it's going to be, and then you can make these calculations to verify for sure.